Hello, my name is Joelle, and this is my lemon fire experiment. So we have all of our supplies together. The first thing we're going to do is take our lemon and roll it so that way it releases some of the juices. Okay, so we have our rolled lemon. Next we're going to add our nails. So first we're going to take some of these copper nails. These are the only ones I could find at the store that were copper. And we're going to place them in our lemon about 1 centimeter apart. Okay, so we have our copper nails. Next we're going to do our zinc nails, also about 1 centimeter apart, across from these. Okay, so now we have our giant copper nails and our smaller zinc nails. The next step is going to be going from the it's going to be connecting the nails with the wire, starting with this copper one to the zinc one there. This is what we got so far. Okay, so this is our finished product. Now we just need to grab our steel wool, our pieces of paper, and the wires to connect everything. Okay, so we have our lemon, our pieces of paper. Just gonna set our lemon down in the sink. So. Then we have our steel wool, and we're just going to connect these with the wire. So we have our connecty wires. We're going to try to get something going with this steel wool and our piece of paper. So far, nothing going. I'm going to try to adjust the wires to see if maybe that helps. Okay, we've adjusted our wires and made them tighter and more closely wrapped to the nails. So we'll see if this has a positive effect. So trying it right now, so far nothing. Trying still to get something going here. Okay, we may have to give up. I'm not sure what exactly went wrong with the experiment. Maybe it was the kind of wire that was used, just like a regular electrical wire. It could be that the nails were just labeled as copper and zinc, but were not actually made of those materials, so that's another possibility. But we'll take a look and see what was supposed to have happened here. Okay, so this is my presentation for the lemon electrochemical cell fire. So our main factors here are, first of all, our copper. That's supposed to have a positive charge and acts as the cathode. The zinc should have a negative charge and act as the anode. Our lemon actually acts as our electrolyte, thanks to an important ingredient in there, citric acid, H3C6H5O7. What we were hoping to accomplish here was an electric current created by flow of atomic particles, so electrons. The electrons should flow from the negative to the positive terminal. This means that the electrons flow from the zinc through the lemon juice to the copper. The zinc metal reacts with the acidic lemon juice to produce zinc ions, which are Zn2+, and electrons, 2e negative. When zinc enters the electrolyte, that results in 2 positively charged hydrogen ions. That comes from the electrolyte H+, and that combines with 2 electrons at copper electrode surface, and that forms uncharged H2. The hydrogen molecules on the surface of the copper from the reduction reaction can then sometimes create bubbles as H2 gas. And then this is just kind of a representation of what's going on here. So this first equation is the oxidation. So that's, as we described, the zinc getting rid of 2 electrons there and then having a positive charge, and then the hydrogen and the positive hydrogen and the electrons coming together for to form like a neutral gas. And this is some zinc and copper here. Then I thought it'd be cool to look at doing some investigating into the first battery. It was invented by Alessandro Volta in the 1800s. This is a picture of him here, and this is a picture of the first battery. He used stacked discs of copper and zinc and connected those with a cloth soaked in salty water. So that was, I guess, like his salt bridge, and acted kind of like his electrolyte there. He also discovered an isolated methane gas. This invention of Volta's in 1791, his friend had discovered that connecting 2 different metals to a frog's leg muscles caused it to twitch. This was called animal electricity. Volta then went on to use electricity without animals, and apparently that was pretty controversial. His battery was also known as the voltaic pile or voltaic column, assumably after his name. And then Volta's experiment was used by William Nicholson and Anthony Carlisle to go on and discover electrolysis, which is pretty cool. So kind of spearheaded things. And then down here is a picture of him demonstrating the battery. So that's pretty cool. Thank you so much for listening.